Now we will discuss how can we represent simple harmonic motion in complex form or complex number form. Let us suppose a vector is represented by a complex form in xy plane. We can draw like this. So x y plane where x is real part and y is imaginary part. Consider a vector of x bar, a vector of x bar whose magnitude or amplitude or absolute value of that vector is a, and the coordinates for this vector in xy plane are real and imaginary plane are small a and small b. And let us suppose this amplitude or this vector is making an angle of theta with the x-axis. Now we want to represent this. So the moment you think of imaginary numbers, you will be having complex numbers. The moment we discuss about complex numbers, it will be having both imaginary and the real numbers. So let's take for this case only. So we want to represent this in complex form. So complex form is nothing but it will be having real part and I times the imaginary part, where a and b, x bar is your vector, a is your real part and b is your imaginary part. And here I square equals to minus 1, which you know very well, right? Okay, fine. Now what I need to do is I need to simplify this and I need to develop a simple harmonic motion equation. So how can I do that? Now, right. From simple trigonometric equations, formulas I'll apply here. Consider this triangle, right? So let's consider this point is point C. Let's consider this point is point C. This right angle triangle consider. Now, what is OA? What is OA? Can I write like A cos theta? I'll be representing it OA, nothing but A I can write it. Now, come for OB or AC. Both are same, right? OB or AC, that it can be written as A sine theta. So this can I write like B? Now you know the A, you know the B. What about theta? From the same right angle triangle, write down tan theta equals to, what is tan theta? AC by OA. What is AC? B. What is A? OA, nothing but A. So can I write tan theta equals to tan inverse of B by A? Right? Now you know A, you know B, you know theta. Now let me write this A in terms of A and B. How can you write? Again, simplify. So what I can do is, let me write this is here equation number 1. Now let calculate. This is your equation number 2. Now, from equation 2, what I am doing is a square plus b square. Left side, these two terms, I will be squaring and adding. So because of that, what happens? I need to balance by doing the same operation on the right side terms also. So a cos theta whole square plus a sin theta whole square. Am I right? Now, what can be done? It will become a square cos square theta, a square sin square theta, where I can take common a square. So, a square cos square theta plus sin square theta, where cos square theta plus sin square theta is 1. So, I can write a square plus b square equals to a square into 1, where a equals to under root a square plus b square. Isn't it? So now I have written a. What is a? A is modulus, or else a is absolute, or else a is amplitude for your vector. So I have written a in terms of a and b. What are small a, small b? These are the coordinates of your vector in real and imaginary plane or xy plane. Okay, now what I want to do is, let me put a line here. Now what I want to do is, this is my basic equation, right? A plus b. What is a? A is a cos theta. What is b? A sin theta. Let me substitute these values in here, this one. Substitute equation 2 in equation 1. What happens? Here x bar, that equals to a cos theta plus I a sin theta. Am I right? Where a is common in both the places. Take out the a. So cos theta plus I sin theta. Am I right? You make this as 1, 2, 3. You take this as equation 3. Now, what is cos theta? What is sin theta? So now you have to recall your mathematics series. So you might have studied Taylor series, right? So what is this Taylor series talks about? As per the Taylor series, here cos theta equals to 1 minus theta square by 2 factorial plus theta power 4 by 4 factorial plus, here it will be minus theta power 6 by 6 factorial plus and so on. Same according to the Taylor series, sin theta can be written as theta minus theta cube by 3 factorial plus theta power 5 by 5 factorial plus, minus, alternative plus or minus. Next, theta power 7 by 7 factorial plus so on. You can ask me, sir, how can we remember these equations? It is very difficult. It's not difficult. There is a simple technique to remember this. Always cos theta series is known as even number series or even series. What is it? If you observe here, powers and these denominators all are even numbers or not? So it is called even number series. Next, sine theta. Sine theta is known as odd number series. Isn't it? Yes. So you can remember like this. And in both the places, alternate minus and plus. It will start. Okay. So now what I want to do is, I want to substitute this cos theta here, sine theta here. So before I go further, okay, let me substitute these values here. So from equation 3, what I can write? X bar equals to A. What is cos theta? 1 minus theta square 2 factorial plus theta power 4 by 4 factorial minus so on plus I. So what is this sine theta? Sine theta is nothing but theta minus theta cube by 3 factorial plus theta power 5 by 5 factorial and so on. Alright. Now I need to simplify this. See here alternate plus or minus is there. Now I will make use of this I square, I cube, I power 4 like that. See, let me write those equations. Okay. Now, what is I square? We know, minus 1. What is I cube? What is I cube? I square into I. Nothing but minus 1. What is I power 4? I square into I square. So, it is plus 1. What is I power 5? What is I power 5? Minus 1. Right? Now, what is I power 6? What is I power 6? I square into I square into I square. Nothing but minus 1. What is I power 7? I power 5. I square into I square into I. I square plus. Right? So, here it is the one. So, how I can write all these things in this way? Now, I will make use of these things in refining my this equation number 4. Let me take this is equation number 4. Now, from equation number 4. So, what is that x bar equals to? A into 1. Here, you see, minus is there. Instead of minus, what I can write? Minus 1 is nothing but what? I square. So, I will write, I'll put plus I theta whole square by 2 factorial plus. Am I right? What is it? What does it mean? I square theta square. What is nothing but I square? Minus 1. So minus 1. So I am replacing this minus with plus by using this 1. Now I power 4. So I theta whole power 4 by 4 factorial and so on. Right? So what I am doing this, why I am taking the help of I square, I power 4, I power 6, because I need to change all the terms positive. So in order to do that, I am taking this help. Now, this is for cos theta. Now, for sin theta also you take such type of help and do that. You just put this inside I theta plus I theta cube by 3 factorial. What is I cube? I cube is minus 1, right? Just check. I cube is minus 1. So I am writing I cube. So what happens? I cube means minus 1. So here it is balanced now. Now I theta power 5 by 5 factorial, and it can be written like that. So let me put the bracket finally. Now this is, I'm writing in terms of I theta like that. Now what I can do, all the terms you have positive, and but if you check, the first square bracket terms are even powered terms, and the second square bracket terms are odd powered terms. Now I will write it in a increasing order. So a into 1 plus I theta whole square by 2 factorial I theta cube by 3 factorial I theta 4 by 4 factorial I theta whole power 5 by 5 factorial, and so on. So what I am doing here, I haven't done anything extra. So I am writing C. Then okay, I theta I missed, right? So it should come like 1 plus I theta. In the place of x, what you have? I theta you have. So what I can write? So x bar equals to e power I theta I can write. So instead of x, what do we have? I theta every time we have. So I have written this. Again I can rewrite this one e power I omega t. So how you got this? So theta equals to omega into t. So this is the representation of simple harmonic motion in complex form. Now we have the displacement. Will the displacement alone helpful in analyzing the vibration successfully? Completely? No. What do you require? Velocity you require. Acceleration you require. So in that case, what do you require? Now, velocity is nothing but x dot. X dot is nothing but dx by dt. So that equals to e power I omega t. Let me write about this. Into I omega. So what I can write here? So what is it? I omega. Sorry, here we forgot this a. So what you can write here? X bar. Right? So what is this equation number? 1, 2, 3, 4, 5. I think 6. I think it is 6. Let me take this as 5. Now, same way, write down for acceleration d square x by dt square. Now, what you can write? A e power I omega t into I omega whole square. Differentiation of e power ax equals to a into e power ax. So same way. So the same formula I am using here. Now what I can write? I square. I square is nothing but minus 1 minus omega square a e power I omega t. So what I can write? minus omega square x. So this is your x double dot. This is your x. So you have displacement, you have velocity, you have acceleration. With all these three, can we conclude something? So always acceleration is proportional to the displacement. Acceleration is in an opposite nature to the displacement. Acceleration is minus omega squared times to that of x. So all these things we concluded even in our previous topic, that is a representation of simple harmonic motion in vector form. So here also we have concluded, we derived the same, isn't it? So both are same, but the way you write the equations is different. So in this case, there is another thing. So we have all these things. Now let me write in a different way of all these 5, 6, 7 equation. 5, 6, 7 equations. Let me, instead of writing, let me represent a graph. So let me take x, y, right? So what is this x? So here it is, here x. X equals to AE I theta. Now, just now we concluded your acceleration is opposite nature to that of displacement. So it will be collinear to the displacement, but in the opposite direction. So this is your x double dot, nothing but minus omega square into x. What about the velocity? Velocity will be always perpendicular to the displacement. So it is I omega x. Right? Now, what we can observe or what we can state from this graph. So we can state in a simple harmonic motion, velocity always leads the displacement by 90 degrees. The acceleration leads the displacement by 180 degrees, or else the acceleration leads the velocity by 90 degrees. So this we can observe from this graphical representation of complex form of simple harmonic motion. Right, okay. You can say, sir, this Taylor series, positive, negative signs alternate, sine series, cos series, exponential series, all these are very difficult to remember. But what I can say is, if it is very difficult for you, okay, no problem. Need not to remember for that. For your better understanding, I have explained. But what you do is, you remember at least, try to remember these equations. How you can represent in complex form? Displacement x equals to a into e power I theta. What is a? A is amplitude. What is theta? Theta is the phase angle. So what you can write? E power I theta. So you can write a cos theta plus I sin theta. You can write, right? So at least this equation you represent. See, if you remember, while we are taking the complex equation, we have taken x equals to a plus ib. Always it need not to be plus in between. You can take x equals to a minus ib also. You can take x equals to a minus ib also. In such case, everywhere this minus will carries over, and here it will be coming 1 minus plus minus plus minus plus, like that it will be coming. So finally you will be getting x equals to a into e power minus I theta. So here you will be getting minus. So that also you need to remember. So that is what about simple harmonic motion in complex form.